Hi there, my name is Allard Buijze. I'm the CTO of Trifork Amsterdam, and I'm founder of Axon Framework, and I'm here together with Josh.
Hi everybody, I'm Josh Long. I'm a Spring Developer Advocate at Pivotal. At Pivotal, we've been doing our level-headed best to help customers and community members and organizations move to microservices. They're looking for ways to go faster and to reduce the size of the batch of work that they have to move through the value chain all the way into production. And we've seen a lot of organizations make this move, and they're using Spring Boot and they're using Spring Cloud to build these sort of distributed systems. And one thing that seems to come up a lot is how do we build distributed systems that have entanglements or have to understand state in other nodes? How do we get different nodes to agree upon state or to converge upon the correct state? One common pattern that seems to come up a lot is Cqrs. So today we're very lucky to have Allard here join us and introduce Cqrs with the Axon framework, which is a very, very nice thing to use with Spring Boot. So Allard, can you tell us what Cqrs is broadly?
So Cqrs means command and query responsibility segregation, right? It basically means splitting components into either something that handles commands, which are the intent to change something in your system, to change the application state, versus the queries on the other side, which give you insight in the current state of applications. And you already mentioned that different components need to agree on a common state, and that's very often the case when you have a lot of different views on the same, essentially the same data, right? There's a lot of different ways to look at information contained in a system, and different people have different requirements for those. And that's exactly what Cqrs will help you do. It will help you focus on the data that you need for each one of those audiences and these users of your data.
And you can do so in a distributed system. Why is this architecture better for distribution? What do we get by building our applications in the Cqrs way? If we want to move to a distributed system versus something else.
Something that is very common with the Cqrs-based system, and it's not. Essentially, Cqrs itself says nothing about distributed systems, but it's very commonly used together with an event-driven architecture, and that's really where the real power of Cqrs comes in as well. You have these explicit messages that you can use. So you have the intent to change something. If you express that intent in a message, then you can achieve location transparency. So you can achieve that one component, the component sending the command, doesn't know or need to know where the component receiving and processing that command actually lives. So that helps you build an application that you can distribute later, even whenever you need to. And the same for when you change something in a system, you can emit events, and these events can then be handled in different components that update specific models for specific target audiences with the data that these audiences require. So you can use these messages and optimize every component separately, which is a very nice combination of features that you can use for building distributed systems.
Ah, very cool. Well, okay, you've piqued my curiosity. Could you show us how to build a simple application? Suppose I had a simple microservice that had some state. Can we build a simple example and see what it looks like to be able to manipulate that state from a service?
So we want to build something quickly, right? So the best way to do that is go to start.spring.io and use something that you're probably very familiar with, the Spring Initializer. So we're going to start a little Spring Boot application. And I've been thinking about an application where we can complain about companies, right? So we're going to build a complaints application.
You do that a lot.
Be a web application. I like to complain every now and then. Yeah, it keeps me it keeps me motivated.
It's cathartic.
So we put web and JPA HSQL DB. Let's throw in some Amqp for a bit later because we want to be doing some interesting stuff. Don't think I'm missing anything right here.
Looks good
All right,
to me.
so let's get started and let's unzip that file and then start our project. All right, so here we are, everything. So this is just plain Spring Boot, right? It gets you started in a few seconds, actually. Unfortunately, we have to manually add in the Axon Spring Boot starter. And currently, we're going to use the release candidate 1 of Axon 3. So Axon 3 is almost done. We're putting a lot of work in getting it out there. But Axon 3 has these Spring Boot starters that really kickstart your application.
Okay.
All right, so that's all we need to do. And then we go to our application. And this is our Spring Boot application, right? Our configuration. So let's start off with building a little API. So a little
Can you make the
REST.
Could you make the font a little bit bigger?
$18.
Yep. Perfect.
So we start over?
No, looks good. Just want to make sure we're all on the same page. I change my font all the time. Very cool.
All right. So we create this REST controller, and let's get a method. It's a public class, static class, and we call
so we're
it
creating
our
a simple API to manipulate complaints.
Exactly. So let's start with a little get mapping. So we have this HTTP GET request that we want to map to, and always use void. I let IDEs do the typing. They do that a lot faster than me. So let's do a find all method. So we want to find all the complaints that we have. And to get that, we need a repository. So we can create a complaint. And this is where the first little Cqrs thing comes in. We create a complaint query object repository. We want to be very explicit about the type of object that we are using. So we are serving out information, which is a query. So we want to be explicit about that. And we create an interface which extends JPA repository. We will be serving out complaint query objects, which are identified by a string, and make that a repository. Now this object doesn't exist either, so we create that. This is an JPA entity, and we have @ID private string, have a private string description and a private string company that we want to complain about. I like to avoid setters. Create a no R constructor and an all R constructor just for later on. All right, so now we have our repository. We can make this final, and we add a constructor parameter. Spring Boot will automatically.
That'll use the new support in Spring Framework 4.3 to automatically inject unambiguous, resolvable collaborating objects into constructors, even without auto-wired, right?
Correct. So that just makes it simpler and less error-prone. So let's make another mapping. So we have our complaint query object, and we want to find a specific one. So we can use a path variable string ID, and we have to mention that in the request mapping and say ID.
So if you're not used to Spring Framework 4.3, then you'll not recognize these @get mappings and @post mappings. These are annotations that are shortcuts for @request mapping plus a specific method introduced in 4.3. Another nice feature.
Yeah, it makes it really clean, right? I like this a lot. And of course, we have post mappings as well. And this is where more of the actual use of Cqrs becomes visible. Let's make it void for now, and let's call. Because
we're going to create something here, right?
Exactly, we're going to do well to file a complaint, and this is a REST server. So we have a request body, and let's just create a map of string to string. Of course, you can create these objects that contain all the data for you, but this is just a quick and dirty way to get our request out.
So
now we need something else.
That'll be a map that you're going to get from a JSON structure, right?
That's right. The JSON structure is translated to a map of keys and values, essentially. So what we need now is when somebody files a complaint, we want the system to do something for us, right? So we're not asking for information, we're telling it to do something. So this is where we pass in a command. And in Axon, you have the command gateway to send commands. And because we have included the Spring Boot starter module, we have all of the Axon infrastructure at our disposal, which is the command bus, but also the event buses, and some more things that we'll see a bit later on. And the command gateway is a very convenient API for sending commands. So what we can do now is we can say send, and we can just pass in an object that we want to send as a command. So we want to send a file complaint command, and we want to pass in some information. So request.get. And this is basically querying or getting data from our JSON structure. Let's say we have a company, and we do request.get description. And we want to return what that method sends back. Now this doesn't compile yet, so it's not complaining about the void. So we need to create this command object. And we'll create it as an inner class because
is there an ID or anything that we need?
I'm sorry?
Is there an ID or anything that we need?
Yes, actually, it is actually good practice to pass in the identifier of the complaint you're going to create. And that might sound a bit weird, like why would you create an identifier before you've created something? But especially in distributed system, it's very convenient to have what's called client-generated identifiers. So actually, we could have a local variable here of type string and use something random. And UUIDs are typically a good value for that. So in that case, we'll have an ID here as well. And now you can see it's complaining about the return value. I can make it return a completable future, and I actually know that this case it's going to be a string. So what this does is the command is sent, and if the command is executed asynchronously or maybe even remotely or whatever, Spring will only send the response to the HTTP post when the command is actually executed. So by the time the UI gets the response, the command is dealt with. But the thread handling this could have been released earlier.
That just works naturally with the async support in the Spring Framework 3.1 and later, right? The completable futures, the async results, etc. Callables.
Exactly. So that's why the Axon API has exactly those same features. You just pass them to Spring, and Spring deals with it the way you would expect it does. So this is actually it. Now we can just send a command, right? So we get a request in, and a command is sent. But this command goes nowhere. There's no component doing anything with this command. So we need to create that as well. And in Cqrs, commands are are executed against a different model than the queries, right? The queries are there to get information out, and the commands are dealt with by a separate model, often referred to as aggregates. It's a domain-driven design concept, and it means it's a number of entities that are kept in a consistent state with regard to data changes. So there is already this data change aspect in an aggregate. So we just create a class, and we call it complaint, because that's what it represents. So I'm putting the aggregate annotation, which is an Axon annotation, and I need to specify at least one field, which is the identifier of this aggregate. So I need to have the @aggregate identifier annotation on it. And now I can create a command handler, and I can, so in this case, we want to create a new complaint instance, right? So when the file complaint command comes in, we want to create a new instance of a complaint. And we pass in the parameter, the command does parameter. So Axon will know when that command is sent, it creates a new instance of a complaint. Now normally you would change the state in this handler, right? Where you've got something coming in, and normally you would do this .id equals, etc. That's not allowed. Well, it is actually allowed in Cqrs, but what we want to do here is event sourcing. So we don't want to store the state of the complaint as is, but instead we want to store all the events that have occurred with a complaint in the past. And if we want to know the current state, all we need to do is replay, or that's actually what Axon does for you. You just replay all the events of a specific complaint that happened in the past, and you'll know the current state. But to be able to do that, we need to separate the decision making from the actual state change logic. So in here we do some decision making, and we could say, Spring has some nice assert methods. We can say has length command dot get company, right? We need information. If we don't know what company you're complaining about, it's essentially useless. If that's okay, then we can apply a new complaint filed event. Pass in some information from the command into the event. Get company, make sure we get the order right, otherwise we mess up somewhere else. And the apply method is something that we can statically import from Axon framework. And this will do two things. It will publish this event internally, and then, so internally in this aggregate, it will apply the state changes that belong with that event. And it will publish the event to any components outside of the aggregate in the application, and as we'll see later on, even outside an application. So we are going to create a little class, company, and then bind it to fields, and then create some getters. All right.
So that aggregate gets created in response to a command, right? Every single time there's a command with that particular command, Axon is going to create a new aggregate, and if you have different complaint IDs or have different complaint aggregates, they only live for as long as that command handler is active. Is that true?
Yeah, that's true. So actually, of course, conceptually they live for a lot longer, but the actual object that's created will only live during the handling of a command, and then the events are persisted, and the aggregate instance is just forgotten about, unless you use caching, of course, which you can do.
And who's persisting the events?
So Axon does that for you in the background. So the Axon Spring Boot starter will recognize that you're using JPA, and it will configure a table in your database for you that contains all the events. And it stores the complaint ID as part of the metadata of those events. So when you load a specific complaint, it can very quickly find all the events that happened as part of that complaint, that single complaint. So then based on those events, it can then reconstruct the state.
Ah, very cool.
And reconstructing that state is done through event sourcing handlers.
And so I could replay, in theory, the whole history, right? I could just, I don't have to have, if I wanted to get back the state itself by event sourcing, I could just zero it out basically and start again, replay the events and get new state again.
Exactly, and that's actually what happens on an aggregate all the time. But you can also do that on your query models. So if you've created a nice model, but discover that you have a different view, or maybe the performance could be better, and you decide to, instead of refactoring it, you can just throw away the entire model and then rebuild it from the beginning of time, actually. So since you first launched the application. Depending on how many events you produce in your application, of course, that could take a long time, but at least you have the choice to do that. And in most applications that are built nowadays, as soon as let's say a manager wants to have a different report for which you don't capture the data, the best you can do is say, well, we're going to build it now, then we'll put it in production in about a month, and then we need to record data for 3 months, and then you'll have your first report. But now instead you could say, well, give me a few minutes to reload the entire history, but at least you'll have your reports based on the beginning of time, at least, of your application's time. So in this event sourcing handler, this one is invoked by either the apply method or when we are loading an existing complaint from a database, which is what would happen if you have a command handler on a regular method saying that you want to update some state. So in this case, you could say the complaint was resolved, and then you can probably put in a happiness grade or something that you want to pass in. But let's stick to the file complaint now. So we have some state to keep, which is the complaint ID, and we get from the event. So when we are loading an existing complaint, this method is called, and the complaint ID is set to the identifier contained in that event. So as I said, the apply method will also publish this event to the rest of the components, right?
You're rehydrating the state of this complaint in that event sourcing handler, basically.
That's correct. Yeah.
Yeah.
And as you add more commands and events to your aggregate, you'll have more of these event sourcing handler method. But in some cases, you'll even have apply methods that apply an event that the aggregate itself is not interested in. It's just saying something changed, but if that change doesn't influence any other commands, then there's no need to keep state for it in your complaint object.
And this event sourcing handler is not a great place to put business logic, right? You're applying the past. You're recording the past here, right? You're making the aggregate.
Exactly. That's very important to realize. You never reject an event, right? Don't put any validation here. Just imagine we didn't put the has length of the company in here. So we have some companies, or at least some data in our database after running this application for a while that has no company data. If we would put the validation in here, we would not be able to load those complaints anymore. They would be rejected. So don't reject the event handler, just accept whatever happened. You probably want to take corrective action if something happened that you really do not want to have happened, but it still did happen. So don't put any validation there, just accept, accept history.
Right.
So what we have now is we have some get mappings that return us data. We have a command gateway that allows us to send a command which emits an event. But there's one little block missing, and that is to synchronize these two models. Right? We've created a query model. We've created a command model, which is our complaint. But now we need to update the query model with that based on that event, actually. So what we need to do is we create a little component, which is a public class. As you can see, I'm writing everything in the same Spring Boot application class. In a larger scale project, you probably wouldn't want to do that, but for being quick, we can do it this way. We do this. We call this the compliant query object. And this one will have an event handler in it. And it listens to the complaint file event. So as you can see, the parameter of the method defines the event we're interested in. There's a few extra parameters you can pass in to get, for example, metadata values out of the event, or maybe even the timestamp of the event, etc. But in this case, that's not too important. And of course, we need our little repository in here, object repository, which we can then just auto-wire in there. And we can save a new complaint query object based on the information we get from the event. Like so. And that's it.
Awesome.
So that was the last missing piece. So we should be able to run this application. And there's always this one little thing that you forget, but if we did, Spring will tell us. No. All right. So we can go back to our little console, and we are going to send a post request, and we want to pass in a header to tell the application that we're sending JSON and some data with it. And this is a little JSON document. Company is, so what we're going to complain about. Let's complain about Apple, and then description. I know I'm on a Windows machine complaining about Apple, but
imagine
my escape key is missing, and that's why I'm using my Windows machine again, because I didn't have an escape key. Please send one. There you go. And we want to send that to localhost 8080. There we go. So this is the UUID that we're sending, and be careful in this rendering that the 2, 3, I guess 5 as well is the speed, and the rest of it is the response. So don't make the mistake of copying everything and then not finding that identifier in your database. So actually now we could go to localhost 8080, and this is our find all method, right? So we get that complaint ID.
Wow.
Then we see the company and the description. And we can even, if we take that identifier, because that's the other mapping we've created, and we get 1. So just, you see the square brackets aren't there right now. It's sending me 1. So let's put in another complaint just to make it slightly more interesting. Microsoft. Well, what do we complain about? Bash doesn't always work nicely. There we go. Okay, I put a little quote that it didn't close here. See, it's Windows, Bash does not. There we go. That was exactly our complaint.
Ha.
And there you go. Now you've got 2 of them. Here's the other complaint.
Fabulous.
So that's our little Cqrs application.
That's a single node though. So is there a way for me to take? What if I wanted to create a read-only view? If I wanted to maybe capture statistics, is there some way I could? I don't want to do all that in here, right? I want to keep that knowledge elsewhere and optimize for that particular kind of storage. How would I distribute
exactly. It? So there's 2 forces in play now. So there's the Cqrs that says, you know, I've got this different view of data. So you want to see some statistics. So let's say the number of complaints of a specific company, right? So Cqrs basically says, well, create a different model for that. And then Microservices says, well, if you do something different, build another application for it, right? Don't put all those features in a new monolith, actually. So what we can do is we can push those changes to Amqp. So let's publish our events out of this application, because right now our event bus is just contained within this node, right? So we want to expose that. So we can do that by saying axon.amqp.exchange equals complaints events, like that. So that's one thing we need to do, and the other one is make sure that Axon Amqp is on the class path. There we go. Release candidate 1 as well. So now Axon Amqp module is on the class path, and it provides Axon with capabilities of sending data to Amqp. And this tells us the exchange that we want to forward these events to is the complaint events exchange. We need to define those exchanges.
So in RabbitMQ, you have RabbitMQ is a broker. It's based on open source, an open protocol called Amqp. Amqp describes the structure, the infrastructure in a message queue. And in Amqp, you have a slight, sort of twist on the classical arrangement in message queues. If you're used to, for example, JMS, you'll be used to a destination to which both producers and consumers connect. In RabbitMQ and Amqp in general, there's a little bit of extra indirection. Producers send messages to exchanges, and then exchanges route those messages to queues, to which a consumer will then listen. So what you're defining now are the moving parts here: the exchange, the queue, and the binding between those two.
Exactly. So I want to make sure I get the right name. So I'm defining an exchange, and then I'm going to define the queue. Just give them, normally you would give them a name. Queue builder dot. Let's create a durable queue. So that's a queue that will survive a restart. And we call that complaint events as well. Why not?
Keep it simple.
Build. And now we need to tell our Amqp, our message brokers, in this case Rabbit, the messages sent to the complaint events exchange need to be forwarded or placed in the complaint events queue. So we do that with a binding. And we can say return a binding builder dot bind our queue to our exchange with, and this is which messages do you want to forward to which queue, so you can pass in filters and stuff like that. We don't want to do that. We want to send everything, so we use star. And then lastly, because this only defines that we want to be able to use these exchanges, it doesn't automatically create them. And it's in Amqp, it's very common for an application to declare the queues that it requires, and they are automatically created by the broker. So I can create.
That's one of the nice things about Amqp, right? That's one of the nice things about Amqp is that you can actually programmatically, in a standard way, create those moving parts, create the exchanges and the queues and so on. Right?
Exactly. So in a deployment, you don't need to pass in, I don't know, deployment documents to the operations guys before deploying this application. Make sure these queues exist. Now you can define that, infrastructure as code actually. So
yeah.
So right now we have our admin and we declare our exchange, and this is just Spring magic again, right? It's just you just put in the
Spring Amqp
exchange call. And then you declare the queue, yep. and then you declare the binding. So this is normal Spring configuration wiring that we're doing here. And now we can restart our application. I have my Amqp management console open, and we should see a queue. Not sure if it there we go. So we see our complaint events queue, and it's completely empty, obviously. So let's push our or post our complaints again. Bash does not work nicely. And now we have one, and in a minute, 2 messages waiting. So our application is right now pushing all the messages all the events that we're creating to a queue. So now it's time to build the other side.
The consumer.
So now,
so far you're showing us. So far you're showing us RabbitMQ. Are there other ways to distribute this coming up? Is it possible to use something else besides RabbitMQ? Possibly.
Yeah, we're
in the future?
Currently looking at Kafka for distributing events as well. I mean, it's a very common piece of technology to share events. But another
maybe
way,
one with
Spring
integration
is, I'm sorry?
Maybe another one would be a Spring integration, just using channels.
Yeah, actually, there's already a possibility to forward events to a channel as well. And essentially, with that, you can use Spring Cloud to forward it to anything that Spring Cloud supports, which I guess is basically anything. So that's one way. And another interesting way is you can actually use the event store as a message source as well. So you can have these components. I mean, the events are already stored in the event store anyway, so you could have a component track the events as they are stored in the event store. And then it will remember where it left off with a token that it receives with every event. So you can rebuild a query model completely by just throwing everything away and deleting the tokens, and it will when it starts up, it will not have a token, so it will begin from the beginning and reconstruct everything.
Powerful.
But now for our statistics application, we're going to keep it simple. We're just going to create a little web application, and with an Amqp, Spring Amqp source, right? We call it demo complaints stats. We download the zip file. We unzip demo complaints stats, and we start this in IntelliJ. So we have a new window with a new application. And of course, again, we need to add a dependency, Axon Spring Boot Starter. Nope. This one. And we will add Axon Amqp as well. So let's go to our application now. So what we need to do is we need to fetch those events from the channel, right?
Yeah.
We do finding a bean, and we return a Spring Amqp message source. So this is an Axon component that allows our event handlers, which we're going to create in a second, to read from an Amqp queue. Let's call it the complaint events as well. Now, normally you would have to build a simple message listener container, if I get it right. Let me just inject that. So the serializer is something you get from the Spring Boot starter. So we do have to create a little default Amqp message converter, which tells us how to convert from an Amqp message to an Axon message. But there's a little trick that we can do, because Spring has much nicer ways to express reading, express the fact that you want to read from a queue, than defining a Spring message, simple message listener container class. Simple. So there's a little trick we can do. We can override the onMessage method here, and just leave it the way it is, and just put in a rabbit listener. And we can say the queue that we want to listen to is, what did we name it? Complaint
event.
Queues complaint events. Right, complaint events. So Spring will invoke this method, and this method will then cause an event handler somewhere to be invoked. And of course, with that event handler is something we need to define as well. So let's create our little complaint statistics class. It's not a bean, we're going to create a little REST controller. We need an API on this. We have an event handler, which is public, doesn't even have to be. And now, of course, we need the API of the other application, right? We need some way to share the information. One way to do that is by copying the class, which is not something you would want to do in, let's say, real life. You would have a dependency on a jar file, or even better, just only have the formal API, which is actually the serialized form of that event as a published document. So you could have a serializer that transforms this into a JSON document and sends that over Amqp, and then you only need to share how that JSON document is structured. But since now both the producer and the consumer are Axon-based applications, we can use the event classes. Just make sure they have the chain.
The nice thing is that they're not passing around the complaint aggregate or the JPA entity. They're passing around events, and that's it. That's all you need to build a good state.
So they have a business meaning, right? Those events are not non-technical. They are very functional objects, and they should make very good sense to your product owner or whoever, whatever business people you build this application for. So let's create a little in-memory concurrent of string, which is the company name, to atomic long, which is the number of complaints statistics. Is that right? Yes. And we'll create a concurrent hash map. Now we can say statistics.compute if absent. So if there's no, when the first complaint for a company comes in, we want to create a new atomic long, and otherwise we want to get it, and then we want to increment that value. And of course we want to have a little request.
Get mapping.
Get. And we want to say we have a map of string to atomic long, which is get statistics. Very nice word. And we can just return the statistics. So there's nothing special we need to do here. So this is just our API.
How do you say statistics in Dutch?
Statistiek.
Oh, okay.
It still has the annoying stuff to type. There's too many T, I's, and S's in different orders that you need to put in. So we're almost there, right?
Looks good.
We have this message source that allows us to read from a queue. We have an event handler, but Axon organizes these event handlers in so-called processors. And processors, by default, they read from the event bus, not from some other source. So we need to tell Axon that this event handler needs to be put in a processor that actually reads from the queue and not from the event bus itself. And by default, the name of the processor is the name of the package. So in this case, it would be com.example, which is not a very nice name. So we can explicitly define now we want this to be in, let's say, Amqp events, something like that. I don't know. Doesn't really matter that much. And now in our application.properties, we can say Axon dot, let me double check if I don't make any typos. Copy paste, there we go. Whoops. So we have axon.eventhandling.processors, and here we specify the name of the processor that we have, which I already forgot, Amqp events. And we say the source of this is not the statistics queue, or what name did we give to it? The complaint events. No, that's not true. That's not the source. The source is this name, is still complaint events. So this is actually the source that we want the Amqp events processor to read from, and that's it.
That's the bean name.
It's just the bean name of this this message source, correct?
Okay.
So
okay,
that
I'm eager to see it.
This. Yeah, let's run it. Let's run and see. So that there's a few messages waiting already, so that should deplete our queue right away. And it's yeah, of course, port's already in use. So of all the things that could go wrong, this is the one that goes wrong. Port is 8081.
Easy enough to fix.
There you go. So let's see if our queue is empty now. Yeah, it's gone. So we go to localhost 8081 and see what happens. Hey, one complaint by Microsoft.
Not bad. Let's see now if we can do it end-to-end.
Let's do some Apple complaint and refresh this. There you go. Here's your Apple complaint. And we can go here and see which complaint it actually was. So that's our other service. Where is it? Apple description, my escape key is missing. And of course, this application was running before the other one, and we were storing information in here that we did not send to Amqp yet, and et cetera, et cetera. But that's another one. The bar. Touch bar. What complaint? Not as nice as I would have expected. There you go. So that's another Apple one.
Your complaints are so timid. Very cool. Look at that. Very easy way to reason about it. If you understand how to make to separate the components logically in terms of commands and queries in the same node, then it stands to be very easy when you do that across distributed systems. Very, very convenient.
Yeah, exactly, and it doesn't really matter where. I mean, I can copy my event handler and put it in the other application, and it will just work there as well, right? And that's what the location transparency gives you. The fact that you're distributing is just a matter of configuration. The logic itself doesn't change simply because applications are distributed. So now you can really start focusing on getting the business logic right first, and then when it's right, you can address the pain points or the parts that you do want to be scalable or you want to take out of there, and then take them out as you see fit. So you don't have to start with a massive distributed system, but you can evolve into one as your application grows.
Awesome. Are there any takeaways, any things that people should understand when they, anything else they should understand before they look at this stuff? Any texts you might read or recommend, rather?
Well, there's a very interesting article by actually by Microsoft. It's called the Cqrs Journey, which is a good read, and it gives you a good overview on a lot of these aspects that are not essential CQRS, but often combined with it, like event sourcing. I mean, CQRS and event sourcing are two completely different things. CQRS and distributed systems and CQRS and event-driven architecture, they're all separate things, but they combine together really nicely. And that's what the document also describes. So it's called Cqrs Journey. And it really does a good job in describing all these little architectural components that you can put together to create a very nice distributed system that is actually pretty easy to maintain as well.
And the project right now is marching towards a 3.0 GA. Are there any features you'd like to have or see rather in the sort of future? I mean, and do you want feedback? Do you want people to try the bits?
Oh yeah, please try. I mean, it's release candidate 1. There's actually already some companies in production with it as it stands right now. Whether you want to do that yourself is of course really up to you, but I would ask you to please give it a try. And since we are not GA yet, we welcome all feedback that we can get to make sure that the API is the most pleasant to work with as possible. And then yeah, we can still make little adjustments to those APIs. So this would be the time to do that.
You know, Allard, you and I have known each other for better part of a decade now, and one of the original places where we talked was in terms of an InfoQ article that I wrote about you many years ago. That
was about Axon. 5 or 6 years ago, I think.
Yeah, and that journey, watching Axon as it's grown over the years, and now the code that we have to write to get a reasonable solution up and running has just diminished to nothing, right? Really well done. I love the result. It's been quite a journey there as well.
I think that, I mean, that's most part of that is the way Spring Boot works, and I think that is, I mean, I was actually amazed myself when I started implementing this. You get to a point like, oh, is that it? But yeah, the Axon 1 and Axon 2 as well, you needed a lot of boilerplate just to get started, right? You needed the command bus and the event bus, and for every aggregate, you needed all these components. Now you put an annotation on there. There's Spring that works really nicely with, you just declare things, and then Spring helps you. And of course, there's the Axon Spring Boot starter in between. But
with the auto configuration.
Everything, yeah, it auto configures everything that you want, and still allows you to modify every bit and piece as you see fit, right? If the defaults aren't your defaults, then you can change them if you want. And that makes it really powerful. So I think Axon together with Spring Boot is definitely something that it gets you started quickly because of Spring Boot. And I always say Axon isn't built to get you started quickly, but it's built to keep you going for a long time. And I think that combination works very well.
I do too. Thank you so much for showing me all this and for showing all of us what's happening with Axon. Very, very cool. And with that, I think we should turn to the questions and answers, don't you think?
Yeah, let's answer a few questions. So if you have them, use the chat to ask your questions, and we'll start answering them now.
All right. Well, that was a very good look at Axon and how to build CQRS-based systems with Spring Boot and Axon. Thank you so much for that, Allard. Now we've got a lot of questions here, so I think we should see if we can tackle as many of them as we can as quickly as possible. Right. First of all, why not use Spring Cloud Stream? Yeah, go on.
Yeah, go ahead. Oh, yeah, that was that's a very good question, and we have some support for Spring Cloud already, which is actually the Spring messaging part. So there are some adapters in Axon But we are looking into better integration with Spring Cloud in general. So yeah, Stream would be one of them. It would remove the
Yeah, I mean, you can use Spring Cloud Stream with the messaging support in Spring, right? Because Spring Cloud Stream creates the message channel for you.
So you can already use the Axon, the Spring messaging adapter for getting Axon messages transformed into Spring messages and then send them over Spring channels, where you could have Spring Cloud Stream, then forward them to whatever they support. But the other thing we're also looking at is, for example, Spring Cloud Discovery. And there's, I mean, Spring Cloud is pretty big, and there's a lot of interesting stuff going on there. But our focus right now is a bit more on getting the APIs right, and as soon as they're right, getting that stuff in is just a matter of time, and not that much time actually.
Right. Let's see. When will the Axon 3 Quick Start Guide be available on the Axon website? I'd reckon right after the GA version of Axon ships. Is that fair?
Yeah, maybe even before, but yeah, probably somewhere around that time. Currently, we've got some people looking at a different way to get the Quick Start Guide up and running. So a bit more interactive than just here's a web page and do what it says, and you'll have a little application going. So we hope to be able to get that in, and otherwise it will just be a page telling you what to do.
Plus, I think today's session was a very good quick start. So hopefully that'll serve some
exactly.
people.
It's something that it's a little video. Well, it has been recorded and it will be published sometime soon. So then we'll act as a little quick start guide, right?
Yeah, absolutely. Since the query object repository is just a JPA repository, would this integrate with Spring Data REST to programmatically generate the query API? Yeah, you can use Spring Data REST to generate the view model for that, the view service for that model. The second part of that question is, any thoughts on how to reduce the amount of boilerplate in accepting commands? Well, okay, so you wouldn't use. Well, okay, the question here for you is, any thoughts on how to reduce the amount of boilerplate in accepting commands through the REST API?
Yes, thoughts, absolutely. We've been thinking about just exposing endpoints where you can send commands. However, in practice, what we see is that you don't always want your events your commands one-on-one as API invocations. Typically, also because you have these class names in there. And as soon as you open up that way, well, there's some potential leaks. So security leaks I meant to say. So yes, we are looking at some way to make it very generic to get commands out, or at least commands in, based on a REST API. But yeah, in practice, we see that there's not a real one-to-one mapping from the front end anyway.
Are there any changes when you are using a different MQ? So in this case, we used a RabbitMQ. I suppose we could use the Spring message channel thing, which would then talk to anything that Spring Innovation could talk to, right? So that would be.
Yeah, right. So Axon in itself only supports Amqp or Spring messaging right now, and in Amqp it only uses Spring Amqp. So yeah, those are the options, and probably, I mean, by supporting Spring Cloud Stream indirectly at the moment, but probably more directly in the near future, we support everything that Spring supports.
Right on. Let me see that is answered. What about AWS integration? And actually, I want to rephrase the question. What does it look like to use this in the cloud in different environments? Are there any, in AWS, it's going to be different from, for example, a more opinionated platform like, for example, Cloud Foundry and Heroku and Google App Engine and so on. Can you speak to that?
There's a few things. First of all, it's just an app like any other application, right? The Axon stuff is mostly within the JVM, at least in our example here. When we get out of the JVM, we use Amqp in this case. You could use, but it's not available out of the box, but you could use the simple queue service by AWS to do that. But for the scalability part, currently we only support JGroups, and you can get JGroups to work on AWS. You just don't use the for the discovery. You just use a Gossip server, for example. But it's not the most ideal, and that's one of the things we're looking at. We're looking at Spring Cloud Discovery is to support that, and that will definitely boost the ability to run Axon-based applications at scale on cloud environments.
Discovery client abstraction.
Axon, sorry?
The discovery client abstraction in Spring Cloud.
Exactly. Yeah.
It uses
but everything in Axon is an interface, so it's relatively simple to implement something very specific to a specific environment. If you have a different way to discover nodes, or have a different way on AWS, for example, you could just use APIs to find all the nodes that you're running, and then discover which ones of those are Axon nodes, etc., etc. So.
Let's see. How about Let's see. How about adoption stats for Axon? Could you talk about who's using it, how they're using it, etc.?
Yeah. Well, there's of course I can not do a lot of name dropping, because Axon is quite often used in actually in mission critical systems, and companies that are relatively secretive about them using it, unfortunately. But I can say there's some very large banks using it. Some of them are using it for payment processing. We've seen stock trading based on Axon. There's a lot of financial applications in general, but also mostly they're transactional systems, and some of them run at large scale. There's one customer called Kazumo. I'm allowed to mention them. They're an online casino, and they have really strong auditing requirements by the government, because they're a casino, so they store the entire history of the application since about 5 years now, or 6 years. So they have billions of events in their, it's actually a MySQL database that they have tweaked and optimized to store that amount of data. So right now we don't know real numbers, because it's an open source project, and names keep on appearing. Every now and then we suddenly see a name that publishes a job posting, for example, looking for somebody with Axon experience. Well, you only do that if you have Axon applications running, I suspect. But we expect there to be at least a few thousand implementations in production right now.
Right on. What about Kafka instead of RabbitMQ? And I think you spoke a little bit about this, but can you speak to that some more?
Yeah, so Kafka is currently, well, not supported, well, not yet. I mean, there's no out-of-the-box Kafka component for Axon. However, it would definitely be a really good implementation for an event bus, and it's on our roadmap. We expect to be able to include it in 3.1. Some people argue that you could also use it as an event store, because basically you can set the event lifetime to indefinite, and then Kafka will allow you to do replays from the beginning as well. I'm not 100% convinced that's a good thing to do, because Kafka is not designed to do that. It is able to do it, but yeah, if you store events for a long time, then it's you better have a system that is designed to store those events for a long time, and preferably forever. So that would be my advice. But yeah, definitely Kafka is a very good way to get events from one machine to many others.
Very cool. Well, I wanted to answer this one. One comment was that he didn't realize you could avoid sticking @AutoWired on a constructor, and I want to point out that that's new in Spring Framework 4.3, which is now in Spring Boot 1.4, which is what we were using in this demo. So that would have worked for anything in the last, I don't know, a few months or this year, basically, since we had a Spring Framework 4.3. So who does the apply method in the constructor? What does the apply method in the constructor? That's the question.
What does it do?
Yeah, I guess that's.
So the apply method does essentially does two things. First of all, within the aggregate itself, so within our complaint, it would find all the handlers, so the event sourcing handlers in there, and invoke them just right away. Right? There's no waiting involved. And when they are invoked, the event is also staged for publication with the event bus. When the command execution completes, there's a little unit of work around that command execution. That unit of work will start the commit process. And the first step in that process is get the events out. So it will go and store the events in the event store, depending on the type of, for example, the Amqp connection that you have. If it's transactional, it will send the events right away as well, but with an open connection, and wait for the commit to, it will come in the next phase. Then there's a commit phase where all the commits are done, and then there's an after commit. So that's how everything is coordinated. But so the apply method will internally apply it, so invoke all the handlers, and then stage it for publications for the rest of the world as a next step.
Very cool. One question was, it seems like the questions aren't working, but then of course there's a question. So, anyway, can you show what the event sourcing table looks like? So we used HSQL or H2 in this, right? So do you have anything you could show us?
Yeah. I shut down the IDE, so they're gone. But I should be able to, because I switched off screen share, I should be able to get screen share back on. And let me first start my SQL Workbench, because I'm pretty sure I have some. Of course, I can talk about it, but let's get it up there. So I should have the table in here. All right, let me screen share. Let's see what happens. All right. So you should be able to see this. And I can select these rows. And here you see a few. So if you're in banking, sorry, this is this is my view of banking, right? You just withdraw money. But you see there's a global index, there's an event identifier, which is a unique message identifier, and this is mainly for correlation purposes. And then there's two blobs, one for metadata and one for the payload. And then within those blobs, you can see the actual, well, in this case, it's just the XML. So by default, Axon uses Extreme to serialize the event. So this is a serialized event. And then there's a description of what the payload is actually is. And the reason for that is Axon will only deserialize the event if there's a handler for it. So it uses lazy deserialization. It's very common that an aggregate publishes events it's not interested in itself, because it doesn't affect any of the state of the aggregate itself. And in that case, such an event is not deserialized when loading an aggregate. And then there's a timestamp, and then there's the aggregate identifier and sequence number, and those are used to load all the events of a specific aggregate instance. So these are not very sensible identifiers to use, but this was for a demo. And then there's a type, which is the type of aggregate. I doubt it's used anywhere in Axon, but we've noticed that this is very useful if you're debugging. So we add the type there as well. In Axon 2, there's a type column as well, and it's part of the unique identifier of the aggregate. In Axon 3, it's not indexed at all. It's just there for us to us and you for debugging. So that's it.
Very cool. I think that should be very illuminating for the requester. Let's see. When can you speak about when the GA will be done for version 3.0? What are the plans?
Ooh, that's a dangerous question to answer, but I'm gonna give it a go anyway. So right now we are on release candidate 1, and we invite everybody to provide us with feedback. And basically, it depends on how much feedback we get. There's a few wrinkles that we have still found that we're working away, but we expect the GA well at the latest at the end of the year, but we expect to be able to do it in the beginning of December.
Very cool. What is the purpose of the ID stored in the complaint class in the aggregate?
All right. So when you apply an event, Axon needs to know which aggregate applied that event, and so the ID field is actually for Axon to be able to identify the aggregate that published events. So when you load an aggregate, it knows exactly which events to load from the event store.
So it's correlation.
That's what it's. Yeah, exactly. Well, and when you load an aggregate from the event store, you don't want to load all the events since the beginning of time and just see which ones apply, but you want to be able to really specifically find those events that have been generated by that specific aggregate in the past and only replay them. So yeah, they correlate the aggregate instance to the events.
Very cool. Let's see. How do you support reporting with distributed microservices?
Reporting in what sense?
That's the question. How about reporting with distributed microservices? I would have thought that would have been kind of the read model kind of gives you what you need there, doesn't it? The idea of having multiple read models. You could use those events to build up a view.
Is it monitoring or yeah? Well, I mean, so if you if you have a read model that consists of a lot of different, so quite likely, and please correct me if I'm wrong, but quite often in reporting you combine information from a lot of different sources. So
yep.
Effectively, what you have is just a new view model that has many sources of its events. So it might be, it depends a bit on how you like your deployment model. If you have an event store per service, you probably need to read from multiple event stores and somehow order those events a bit. Yeah, basically you just have a different view model, and you pick your events from any source that you want. You combine them, and then build your view model. And that's the part I like. I mean, it's not really that different from anything else. It's just events as a source, and you build whatever you think is useful to provide your end users.
Very good. Let's see. Oh, yeah. The question has been refined. What about reporting across databases? How do you do SQL joins? But I guess that I think the answer you just gave speaks to that, right?
Yeah, exactly. So you don't really well, there's two ways to it, right? You could either use a combined stream, so you stream events from multiple sources, and then create a nice reporting model, or do it, I guess, the way that some microservices at least do it, is you query one and then query the other one and join the data that way. I'm not sure if that's really efficient, but everything depends. So it depends on how does it need to be fast? Is it a frequent query? Is it a once in a year style query? Or so there's different options there. But my first thoughts go in the direction of combine those streams and build a model out of that information.
But if we learned anything from Ghostbusters, you should never cross the streams.
No, well, it depends. I mean, it gives you very powerful things, right? Sometimes you really need it.
Let's see, what else we got here? How do you ensure that the event
didn't
is
that have to do with Zool, by the way? Never mind.
Yes,
that's off topic.
How do you ensure that the event is saved to the event store and sent via Amqp atomically? How would this work with, for example, Kafka and a NoSQL store?
Yeah, so that's a good question. And well, we're sending data to two different systems. So a guarantee doesn't exist, but we can get pretty far. So in this case, what happens is a transaction is started, and since we're using Spring, it's using Spring's platform transaction manager. And the platform transaction manager can hook in a lot of different transactions. So it can combine the database transaction and the Amqp transaction in one. Well, in kind of one, because the commits happen very shortly after each other. What Axon does do is it will send the data to the event store and flush any data. So it will force the data to go to the event store. Then events are sent to Amqp, and then the commit happens for both of them. So that's how it can see it right now. If you need stronger guarantee, there's an alternative. You can store it to the event store only, and then have a. I'm suddenly getting feedback, by the way, but then you have a processor track the event store and send everything it finds to Amqp. And in that case, well, you have at least once delivery guarantee in that case, which might be better than an at most once guarantee. But exactly once, I mean, it's been said many times that there's still a lot of debate around it, but it doesn't exist. There's no way for two systems to guarantee on mutual state
without quantum entanglement. Let's
exactly.
see. Oh, I'm being told I should mute my line. That's probably what the feedback is. But since I need to talk, we'll just leave it as is. Okay, so would Axon be able to support a distributed write model?
Yes. Was the question will or does? Because
would Axon be? Yeah, does Axon support a distributed write model? I think that is actually two-phase commit kind of discussion as opposed to writing to two different things, but stack it any way you want.
Well, the way Axon does it is more, so you have these aggregates, and an aggregate will always live in one location, right? An aggregate instance will live in one location. If it lives in two locations, then you get some problems further down the stream that they're trying to insert the same event into the event store, which is then rejected. But the way you can distribute it, you can shard your aggregates over multiple nodes. And Axon does have a distributed command bus. And if we had an hour and a half for the webinar, then I could have shown that as well. There's actually a starter for it as well. It's the Axon Spring Boot Starter JGroups. And it allows you to start up nodes, and then these nodes detect each other. And they start sharing or balancing the load among each other based on a consistent hashing algorithm. So every client will know to send a command to a specific node simply because it targets an aggregate, and then based on that aggregate identifier, you can find the correct node to send it to. So that's how you can at least scale the command side and get some distribution over there. What you cannot do and should not do, by definition I would say, just to be really annoying, is distribute a single aggregate over multiple nodes. because the definition of an aggregate is a group of entities that together act as one with regard to data changes. As soon as you start distributing that, well, that's not my view of simple systems, simple to maintain systems.
It's not an aggregate.
It's not an aggregate anymore, exactly.
If events need to be processed by consumers in a sequence, e.g. consumer A must process event X before consumer B, how do you do that with Axon?
Interesting. Here we go again. Sorry. It depends. So if two consumers are part of, so remember I was talking about these processing groups and these processors. If they are part of the same processor group, there are ways to define that the consumers should be invoked in a specific order. If they are part of different applications, then there is no guarantee.
Sorry, gotta go.
So then there's no guarantee at all for any consumer to handle the event before any other one does it.
Cool. Alrighty. What else do we got here? I think we're actually at a good. Oh, there's another question: how to scale the commands, but I'm not really sure I understand that.
I think that has to do with what I said earlier with distributed command bus, and then that's how you can scale them, right?
Right,
and then have multiple nodes concurrently dealing with events, as long as there are for different aggregates, right? All the commands for a single aggregate are always invoked sequentially. That makes the programming model of aggregates nicer, but it also makes an aggregate, because by definition you cannot concurrently execute stuff on an aggregate.
Good point. Good insight. By the way, going back to that question about reporting for reporting across different microservices, there's a good. My friend Ben Wilcock is just pointed me to a very good resource, the Microsoft Developer Network. They have a book called an ebook, a free book called the Cqrs Journey, and I guess they speak to that a little bit in there as well. So check that out. It's free, freely available. Looks interesting. Okay, so last question: how does Axon fit with Vertex, which is more of an event bus, right? It doesn't actually solve the problems of Cqrs. Yeah. It's just an event bus across different nodes.
I'm still finding ways. So some people I know are very into Vertex, and they've been trying to see how does it fit with Axon, and I think Axon is a bit larger than Vertex, just in the scope of the architectural pattern that it tries to address. Vertex is more of an event handling mechanism, right? Everything. I mean, there's a lot of concepts that are similar. So Vertex has this event loop, and then every action is its own little thread or a process. I don't think they really use threading, but they use some other mechanism. But and then everything is its own event loop, right? So yeah, you can build stuff with Vertex. I have never seen a very nice combination of the two that I thought, it does work for samples, but I would never build an application as far as I've seen right now based on both technologies. So if one fits, then probably the other doesn't, and vice versa.
Cool. Very good. All right. I think that's it, my friend. I think we did it. I think we got through all the questions, and this time it only took 25 minutes instead of the 27 or so minutes it took last time. So I think we did pretty good.
All right. Well, I hope everybody's. I answered all the questions to the satisfaction of whoever asked them. So.
Right on. And
of course,
for
if
those
you have
of
any questions, just get in touch with us, right?
Right. We're on the internet. You got our Twitter information in that slide there. for those of you still on the line, thank you so much for joining us. This video has been recorded. It'll be available online on spring.io/video within a week or so, I'd imagine. It's not entirely sure, but probably it might be sooner than that. Who knows? And we look forward to seeing you again in our next webinar, our next installment. So thank you very much, and have a good day.
All right, bye.